All right, our next unit is Unit 8, and it covers Chapter 11, which is polar, parametric, and vectors. But it's not vectors like we've done, well, it's vectors like you should have done in pre-cal. And it's a lot of things we've already done with position, velocity, and acceleration, but now it's in 2 dimensions. Well, yeah, and everything's changing with respect to time, as usual. So I'm going to do some intro videos, because I'm not sure what kind of background y'all have. So first off, we're going to start with just basic review of polar coordinates so that you can graph things and use them in calculus. The first thing you need to know is that for rectangular coordinates, whereas we always do everything in terms of x and y, in polar coordinates we do it in terms of the radius and the angle. Now, you can't exactly graph curves, which is polar graphs, unless you can graph points. So first we're going to go over how to graph points. And what's going on is we have, this is a coordinate in polar, and it is a radius and an angle. So what this is saying is the radius is 4, and the angle is 2 pi over 3. And this is where you're going to have to review unit circle again, because you're going to have to be very fast at this. So what's going on is I always start with the angle. So this is the angle, 2 pi over 3. And then there's a radius of 4, and we look at this, and it's not labeled. It should be labeled, but this is 1, 2, 3, 4. So this is 4. So the intersection, the point is where you have the radius of 4, and you have an angle of 2 pi over 3. So this is A. That wasn't too bad. And I'm going to erase what I don't need, because I'm going to be doing several graphs. Okay, so for our next one, so that was A. Now we need to do B. And in B, we have a radius of 3, and we have an angle of 7 pi over 4, which I know by it being greater than 1, that it's got to be, well, it's one angle beyond, so it's 7 over 6, so that's got to be the third quadrant. So I'm going to go, and I'm going to go third quadrant. This is 7 pi over 6. And by the way, these are labeled for you. They will not be labeled for you, probably. If it's like my test, I expect I'm going to give you a blank graph, blank grid, and make you graph something. I'm probably just going to have the tick marks and not label it, more than likely, because you're supposed to know these. You have to know the common ones. By the way, I guess I should review this too. This is pi over 4 right here. This is in twelfths. So this is pi over 12. This is 2 pi over 12, which is pi over 6. 3 pi over 12, 4 pi over 12, which is pi over 3. 5 pi over 12, 6 pi over 12. So this is all twelfths. And the ones you're used to using, the convenient angles of the unit circle, are pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, the ones labeled. Okay, I've got them labeled, all except for the pi over 4s. We don't label those because y'all are supposed to be able to spot that this is 3 pi over 4. That this is that, so that's this 4 pi over 4. That means this is 5 pi over 4. 6 pi over 4. This is 7 pi over 4. And then this is 2 pi, which 2 pi is equal to 8 pi over 4. And I wrote this as 8, and it's supposed to be 4. Let me change my eraser. Might as well just start over. Here we go. So this is 7 pi over 4. And it's if we do thirds, it's 6 pi over 3. If we do sixths, it's 12 pi over 6. That's 2 pi. And you need to know that. All right, so let's graph B. B has a radius of 3. Now, if it's a positive number and a positive angle, then that means at that angle you are going out that radius. So if we're at pi over, or 7 pi over 6, we got to go 1, 2, 3 right here. I'm going to change that to the green one. So I'm going to put it this point right here. That's point B. And then if we point C, we go to 5 pi over 4, which is this one right here. This is 5 pi over 4. And I want a -2. So whenever we do a -2, what we're doing is, instead of having 2 on the positive side, meaning towards that positive angle, it means you're going, because what do we do when we do negative numbers? Negative numbers are across the origin from positive numbers. Well, on polar, negative radius is across from the pole. This is the pole, which is like the origin, and we even label it 0, but it's a 0 radius. But it's across. So I go, if it's pi over 4, I got to go over here, and I got to go 1, and I got to go 2. So there, that's a negative. It's a negative radius on the angle for 5 pi over 4. So this is point C. And then our last point is, hang on, I need to change my palette. I got it fixed on the other one, but it's, of course, I'm on a different one now. And for our last one, we're going to do point D, and it is a negative angle. For negative angles, it means that we go counterclockwise. So positive angles, let me just write this down. So if your angles, that didn't work out well. Angles are greater than 0, then you're going counterclockwise. If your angles are less than 0, you're going clockwise. So for negative angles, we go this way. This way for negative angles. Oh, let's just rewrite that. That way for theta less than 0, and then we go this way if theta is greater than 0. And since this is a negative, it means we're going down here to the 11 pi over 6. 11 pi over 6 is equivalent to negative pi over 6. And then we have a positive radius, so that means that so we go, we'll come out here. This is for D, and it's a positive 2, so we just do a positive 2, 1, 2. So here, that's D. I'm going to actually put this in black because you can't see it. There we go. That's D. All right, to recap, if it's a negative radius, for a radius less than 0, you're going to go across the pole from whatever angle it is. If r is greater than 0, it's on the same side of pole. All right, now moving right along. Now, things you should have learned in pre-cal. You should have learned a lot of things, but we know how that goes. So let me draw. Well, let me find where my pen is for starters. There it is. All right. So I'm going to draw a right triangle. And if you remember in pre-cal, everything was based on the right triangle. It still is. So we have some angle here of theta. This is our x coordinate. This is our y coordinate. And this is our radius on our unit circle. So we have some point out here on the unit circle. And there are two ways to write the coordinate for that point. There's the rectangular method, and that is x comma y. And then there's polar, which the same point can be designated as r theta. And the relationships between them is what you learned in pre-cal. In pre-cal, you learned that x, in this case, because of SOHCAHTOA, x is equal to the radius times cosine of the angle. And you learned in pre-cal that y is radius sine of theta. Because if you think about SOHCAHTOA, right, if we're talking about cosine, cosine is the adjacent. So if we go over here, cosine is the adjacent, which is x over y, right? And sine is, no, it's x over radius, sorry, radius. Sine is y over radius. So if you solve for x, so what we're doing is we're solving for x, that means we multiply both sides by the radius. And so x is equal to r cosine theta. Y is equal to r sine theta, and tangent, which is y over x. If we want to find the angle, angle is equal to tangent inverse of y over x. And you have to be a little careful with this. You should use the bow tie angles, because remember, inverse tangent's only defined in the first, this is only in the first and the fourth quadrant. That's where inverse tangent is defined. So if you're in another quadrant, you have to pay attention to the bow tie angles. All right, so from back when you were in geometry, probably the last time you did it, you should have covered it in pre-cal, but heck, I don't know what happened last year. But anyway, you learned the coordinate system for the equation for a circle was x squared plus y squared equals r squared. That means r is equal to the square root of x squared plus y squared. All right, so what equations do you need to go back and forth between rectangular and polar? You need these equations, which for the x and y, it's just using SOHCAHTOA, what you already knew. This is a very common equation you're going to have to know. You have to be able to do the tangent, whole tangent things, which that's the tangent inverse. You just really need to remember tangent theta equals y over x, and then you can always do the inverse. But I really recommend that you also know that you use the bow tie angles on the unit circle. If you need help with that, let me know. Okay, here's our example. We have, this is our radius is 2, and our angle is 5 pi over 6, and they want the rectangular coordinates, which means we want x and y. So that means our coordinate is going to be x, so we want xy. Well, xy, that means that it was x is equal to r cosine theta. Well, let me just write it right here. R cosine theta, and it's r sine theta, which if we just plug these in now, it means that this is equal to 2 cosine of 5 pi over 6, 2 sine of 5 pi over 6. And you have to know your unit circle. You have to have it memorized or you know how to get these right. So the coordinate for this in terms of rectangular coordinates is going to be 2 times the cosine of 5 pi over 6. Well, 5 pi over 6, that's in the second quadrant. So I know cosine is negative because the x is negative in the second quadrant. And for 5 pi over 6, that's square root of 3 over 2. And this is going to become 2 1/2, because in the second quadrant, the y is positive, which when you simplify this, this becomes, hang on, let me make this a little smaller. There we go. And that means that the answer for this, I'm going to put it right over here, is just, well, actually, I'll go over here. And the 2's cancel out, and you get a negative square root of 3. And the 2's cancel out again, 1. So that is our answer in rectangular. And you do need to be able to go between polar and rectangular. All right, this is a rectangular coordinate, and we want to convert it to polar coordinates. Now, there are 2 approaches. You can just use the formulas. You can. Or you can use a drawing. So back to that right triangle, really ugly right triangle. From this, this is telling me it's actually in the 4th quadrant. So actually I should just draw in the 4th quadrant, make our lives easier. So what does it look like? It is 3. So this is 3. This is negative 3. That means this is a 45, 45, 90 right triangle, which means it's pi over 4. And in the 4th quadrant, we know that that's 7 pi over 4. So this angle, that angle is 7 pi over 4 because it's a 45-degree angle. It's kind of obvious, right? So the only question is, what's the radius? Well, the radius is pretty easy. Hang on. I don't like that. Try again. La, la, la. Oh, no, I didn't do that. And we'll come over here. So we know that that's pi over 4. That is a pi over 4 angle, right? In the fourth quadrant. I'm not having any luck with drawing this. There we go. So in the fourth quadrant, since this is the fourth quadrant, the angle has got to be 7 pi over 4. And our radius is going to just be equal to x squared plus pi squared. Remember to put the parentheses around it. Because -3 times -3 is 9. So our radius, remember this, r squared is equal to x squared plus y squared. So if we take the square root, we get r, which is the square root of 9 plus 9, which is 18, which is going to be 3 square root of 2. Looking at this, I know that the tangent of 7 pi over 4 is equal to -1. And so there's two ways to you could also refer to this as negative pi over 4. Because when we do the inverse, so basically what we're doing actually is inverse. And let me show you what I'm talking about. So this is the angle is equal to tangent inverse of the y, which is -3, over the x, which is 3, which is -1. Which that means the angle has to be, if it's -1, it has to be negative pi over 4. Because remember, it has to be in the first or fourth, and this is definitely in the fourth quadrant, so we would designate that as negative pi over 4 instead of the 7 pi over 4, because of the definition of an inverse, in the way that you have to be continuous between negative pi over 4 and pi over 4 over for inverse tangent. That's by definition. All right, there's another possibility. So that's 1 point. 1 point is going to be a radius of 3 square root of 2 and negative pi over 4. Well, for every angle like that, you can if you have a negative angle, you can also write this in terms of a positive angle by flipping the radius. You go across. So basically in the fourth quadrant, so what we've done is we've done a negative radius, a positive radius and a negative angle by going clockwise. We say this is negative pi over 4, right? And we have a positive radius of 3 square root of 2. Well, we can go all the way this way too, this angle, right, which is the positive angle. Well, that angle is 3 pi over 4. But if you put a negative radius with it, would it put you at the same point? Yeah, it would. So the other way to write this is a negative 3 square root of 2, and the angle across from negative pi over 4 is 3 pi over 4. So those are two possibilities. And then you could also rewrite them. You can also write them. You can write it any combination that gets you the same point. So instead of doing the negative pi over 4, we can also do 7 pi over 4, which doesn't work with the inverse tangent, but we're just talking about naming a coordinate, and we don't really care. So it's like the whole spinner thing where you can get the same thing, same angle, using multiple spins. So we could also designate this as, no, with the negative, 3 square root of 2, comma 7 pi over 4. And we can keep going round and round and round and keep renaming it. But generally you just need to know the positive and negative. All right, so that's going that way. Okay, now we also have to convert equations. Not just points, but equations. And the way you got to do this is you have to know what y is. You have to know what x squared plus y squared equals. Well, y, from SOHCAHTOA in that drawing we did, is r sine theta. So this equation, r, we tend to solve for r, is 4 over sine of theta, which equals 4 cosecant of theta. Either one of those is acceptable. For this one, radius squared is equal to x squared plus y squared, which equals 25. Which gives us two equations. If we take the square root of both sides, we get two answers. R is equal to 5, or R is equal to -5. And both give you the same circle. We put a box around our answers. That was easy peasy lemon squeezy. You are going to have to use those equations. You're going to have to learn to use them. All right. Next. All right. Now we're going to convert some equations to rectangular form. So we converted rectangular to polar. Now we're going to go the other way. Well, looking at this, did we just use this? Didn't we just use this? R sine theta is y. So this is just y equal to 3. Well, y equal 3, 1, 2, 3 is this right here, right? There's y equal 3. And whereas in pre-cal, they should have made you put points in there. Because we're in calculus now, that's not my biggest problem. My biggest problem is making you understand what you're doing and then using it in calculus. So I don't care about points. I just want you to draw the horizontal line at 3. For our next trick, we got to look at this and this is definitely not x. There's an r missing, right? Well, what if we multiplied both sides by r? We would get r squared. Is that something we want? Yep. And then this is 2 times r cosine theta. Well, what is r cosine theta? And what's r squared? R squared is x squared plus y squared. And r cosine theta is x, so it's 2x. And what you have to do here is you have to complete the square in the equation of a circle. This is a circle. And once you get into the graphs, you'll recognize the patterns. But this is a circle that has a diameter of 2. I know this. So I know what the equation is before I do anything. That would just be, and it's shifted because this is on the x-axis and it starts at the origin and it goes out to 2 on the x-axis, the positive x-axis. So I know it's centered at 1, 0. I can look at this and I can write the equation. But you can also get it with algebra because all you have to do is move this to the other side. We get x squared minus 2x. We're going to complete the square plus y squared equals something. So the way you complete squares, if you remember, is this is b. So your b is -2. -2 divided by 2 is -1. -1 squared is +1. So I add 1 to both sides. And this whole thing becomes x minus 2 squared plus y squared equals 1, which means it is a circle centered on, it's a circle centered on, come on 1, 0. I don't know why it's doing this. It doesn't like me today, apparently. There we go. Yeah. I don't know what the heck's going on here. Go away. Let me see if I can slide it a little bit, if that'll help it. So we're going to put a point here. Why do you do this to me? I want a point there. Stop it. And okay, and then we're going to put a circle centered there. I'm just going to draw it in. So it has its diameter's 2. So 2, no, diameter 2. So it's a radius of 1, radius of 1. So it goes like this, and then it goes like this. And I can't tell you how, it just takes a lot of practice when you're using a pen. I'm using the new Wacom pen, and I'm just really bad at it right now. And it's not behaving anyway. I'm not sure why it doesn't want to do this. I don't want you to do any of that. Just let me draw. Okay, close enough. It's a circle. Okay, and for our next trick, we have to get back to angles. Oh, angles. What the heck do we do here? Well, the only thing that had an angle in it was the tangent. So we know that tangent of 2 pi over 3, what does that equal? Well, it equals negative square root of 3, and I know this because it's the it's at pi over 3. I know the cosine's a negative a half, and so let me just go ahead and write this out. So this is x over y, but I know that for this point, the tangent, it's y, which is well, say that it's square root of 3 over 2 divided by negative 1/2. The halves cancel out, or if you flip it up, it's like multiplying by negative 2. So this equals negative square root of 3, and that is equal to y over x. We are going to solve for y by multiplying by x on both sides, and that gives us the equation y equals negative square root of 3x, which means it is a line with a negative slope that goes through the origin. So it goes to the origin, and it has a negative square root of 3. I know that square root of 3 is somewhere between 1 and 2, because the square root of 1 is 1 and the square root of 4 is 2. So it's somewhere between a slope of negative 1 and negative 2. So it's closer to the negative 2. So I'm going to go a little bit less than a negative 2 and just draw a line in. It's not so much. This is just getting you used to this stuff so you can handle what you're going to have to do eventually. All right, this part is calculus, and we will save that for class. So this is the first intro, just going over basics of moving back and forth between rectangular and polar coordinates.